work here. So you know that, and those of you who use Kafka Streams know, a topology is the way that we talk about how Kafka Streams run. So at its core, it's a source, Kafka topic, some processing, and then a sink. You put it somewhere else. So that, in a nutshell, is Kafka Streams. And there's infinite possibilities in terms of those topologies. So it got me thinking that, it's kind of like choose your own adventure books, where if you have this situation, use this. If you have this, and I was like, that'd make a really cool talk. So then I submitted it and it got accepted, and when I started writing this talk, I was like, oh, this is kind of difficult. Maybe I should have just done a normal talk. Oops. Anyway, so you're all here. If it stinks, sorry. No, just kidding. It's gonna be awesome. So it's a lot about choices. And life is full of choices. I'm a huge Indiana Jones fan, so in the quest for the Holy Grail, the choice is lots of cups. That's not Indiana Jones, for anyone who hasn't seen the movie, but I like that picture better. And in Kafka Streams topologies, there are lots of choices. You've got keys, semantics, time, state, stores. And just like in life, if you choose poorly, the quest for the Holy Grail, you turn into that skeleton guy. It was so creepy when I was a kid. And Kafka Streams, if you make poor topology choices, it can incredibly impact your application. I've seen it happen to tons of people, and it's just sad, because it could rule, and it doesn't, because you've made poor choices. You have data loss, performance issue, fragile code, which nobody wants to change. We all have those services, right? Where you're like, not it, I'm not touching that one. Incorrect results, and then horrible death. Like the last one's not true, but I kind of want to up the stakes, so there's the foreword, because it's like a book. It's like a theme. When I was first starting to do this, and I loved Kafka, like proper, 110%. And I thought, oh, this is going to be awesome. Now all my data's in Kafka. And I was like, oh, crap, now what do I do with it? And so I started looking at event streaming, because I love eventing. It's basically the bread and butter of what I do, is event patterns, just anything event-driven. And I was like, okay, well, I've already sold Kafka, and we had to get, all new boxes, new hardware, everybody to train up to do that. How am I supposed to sell another dedicated cluster like Flink or Spark? That's not going to go over well. And then I was like, oh, look, there's a Java library. Sweet. And that's kind of the difference, in essence, of Kafka Streams versus other streaming platforms, right? It's just a Java library. And for a lot of places that are Java shops, it's very home for them. And so to me, it's a great way to get your feet wet with eventing without having to sell a lot to various, people who make choices about what we use and don't understand it. I'm sorry, what does that mean? And then one night when I was trying to sleep, which never works well for me no matter what country I'm in, I was thinking, well, how are you going to explain Kafka Stream scaling? Because in order for us to go through this wonderful adventure, you need a little bit of groundwork. And then I thought, oh, it's like sneakers, because I love sneakers. It's like my high tops. These are my brand new ones just for today. So for those of you that don't know about sneakers, which I don't know anyone who doesn't, but somebody said, like, you should tell them about sneakers. People might not know how they're made. I'm like, well, all right. There's an upper and there's a base. The upper is comprised of various parts, like the tongue and, the side pieces, and so is the base. Usually it's fused together with a hard outer core and then like an absorbent material. And it might look like this if we were to look at a production line. You've got one part that's responsible for finishing the uppers of a sneaker, one that's responsible for finishing the bases, and at the end, you join those two products and you get a finished sneaker. In Kafka, now how many people use Kafka proper? Like brokers. If I say offset, you say, what, right? No. So for those of you that don't, I don't want anyone to go into this talk and not understand and be like, this is meaningless to me, because I did not fly over here and be jet lagged for this to be meaningless to people. So I'm just gonna take us back a little bit. So in Kafka, the base of parallelization is a partition, and that's very important. In other messaging systems, it's a queue, right? In and out, it's gone. I hate that. Kafka is a distributed log, right? It's immutable. It's the most beautiful thing in the world, because it doesn't go anywhere. You can count on it, and I love immutability. And so when you think about a topic, really your unit of scale is partitions, and that's nowhere more true than in Kafka Streams. Now, there's a lot of work, and I said I wasn't going to do this, but I'm going to do it anyway. There's a lot of work going into talking about if you keep that restriction, because it's one of the things that hold people back from adopting Kafka Streams, because you scale out to the number of partitions, when in fact, you really only have to scale based on key. So there's work being done right now to kind of relax that and allow Kafka Streams to scale even better than it does today. So that's just something that's coming for anybody here who's thinking, I'm never going to use that because it's restricted on partition. Well, not for long. Hopefully, we can get Matthias working on that. I know where Tim is, but let's do it. And so if we were to look at these, production lines, and we were to say, okay, we've got these topics, upper and bases. They're comprised of 3 partitions, right? Let's say red, blue, and green. A couple things become apparent. So Kafka Streams works in terms of stream tasks. Those stream tasks are assigned to a partition, and that's very important because it means that inside of them they're independent. Because remember, in Kafka, order, again, is only ensured inside a partition. So you can reason about things immutably inside a partition. So when Kafka Streams runs, it says, okay, I can scale out to the number of partitions because I know if an instance goes down, I can migrate that task. It's all nice, comprised, beautiful, and composed, right? So in this case, we would have 3 partition/stream tasks when we run in for uppers, bases, and when you're looking at this, something else should become apparent. And this is kind of why people get hung up on joins. If I were to have, let's say over on the bases side, I only had 2 partitions. What's the maximum number of lines I could have for finished sneakers? You can only have 2, right? You can't have 3 people if you only have 2 lines for bases. So that's important to note that when you're doing a join or your unit of scale there is going to be the minimum number of partitions. So whatever the lowest number of partitions you have for your inputs, that's going to restrict your scaling. And all of these concepts are things that are very confusing to people when they use Kafka Streams for the first time, and it kind of bites them in the butt. So I'm going to preface it with that. You should remember that. So how many people here know what a topology is? We just talked about it. You should, if you were listening. Nobody? Wow, I'm horrible at this. I should yank this. I'm never coming here again. No. So topology, again, right? It's a source, it's some sort of processing, and then it's a sink. And Kafka Streams very wisely breaks these down into subtopologies. So they're the independent processing. So for us, we'd have 3 subtopologies. One for uppers, because if the baseline goes down, can the people who are making uppers still work? Yes, right? Unless they feel bad like for their friends or whatever, I don't know. But they can, they're independent. And the same with subtopology 3. If you have those inputs and you've already got them out, they're independent. So this would be like 3 subtopologies. So here's chapter 1. This is where it's going to get weird because I had to theme this. So I don't know about you, but again, I was a principal software developer for 16 years. And sometimes you would get a JIRA with like this much information. And you're like, seems legit, but so this is one of many JIRAs that I would have, and they can do it. So you have 1 sprint to event, stream, sneaker production, or else. And then I have PS, find out who's been taking extra coffee breaks. Because there's usually like a little thing in there like, and do this. So this is our story that we're going into. So we have to event, stream, sneaker production. So the first thing you always want to think about, and this is very important, a lot of times, like how many people have written Kafka Streams applications and they've already had topics defined for them, and they're like, pull from here, just do it, right? So sometimes you don't get to make that choice, but a lot of the times you're the one that's setting it up for the first time. So that's where you start. You always start with, okay, let me look at my topic that I'm inputting into Kafka Streams. If you have that, if you can do that, that's what you do. So we're going to choose keys. Now, keys in Kafka is how you decide what partition a message goes to. It's a hash, right? And we're going to talk about the various options. So you could use no keys in our example. You could key both of them by color. I mean, we know we're probably going to have to reason about color as an entity, right? So maybe that's a logical choice. Or every single thing that comes in has an upper ID written on it. So this goes here, and bases have a base ID, the finished product. So maybe we key by those. We'll see. So if you use no key, then what you're giving up is a guarantee of order inside of a partition for a given ID. The best example of this ever is invoices and credits. So invoices have an invoice ID, and then you credit that invoice, right? If you want to make sure that the invoice always comes in before the credit, which most companies do, then you've got to key by that ID. Because again, order is only guaranteed inside a partition. So you have to make sure that if you care about the order of things, that's what you key by. And in our case, occasionally somebody messes up, and I just said uppers are sent back for restitching. So let's pretend we do care. We say, okay, I want to know if this is the first time that upper's going through, or if somebody's sewed over their thumb. I mean, they were talking about hurricanes earlier, so I guess that's valid. And you got to send something back. So we do care about order, so we can't use no keys. Key both by color. This is so common that I see it all the time where people go, I want to reason about this in color, so I'm going to key by it. We only have 3 colors. So right there, you've just limited your scaling to 3 partitions, number 1. Number 2, hotspotting is not a good thing. And hotspotting happens when you don't have equal distribution across partitions. So Kafka doesn't know anything about your partition load. So Kafka Streams right now, as it stands, it's not going to treat, like if you have one partition that's overloaded and the other 2 are light, and it needs to break those partitions among instances, it's not going to go, oh, I'm smart enough to know this partition's overloaded, so I'm going to put this one in this instance and then give this one the other 2. There's no guarantee like that. So if you don't have equal distribution of your messages across your partitions, you're going to get hotspotting and you're going to run into problems, which means like processing delays, you're going to have an overloaded instance, your state stores are going to bloat. It's not a good thing. So avoid hotspotting at all costs. What we like to say is if you don't care about order, don't use a key. Only use a key if you have to. So we're not going to key by color. It limits our potential for scaling, and also apparently like people like red shoes, so we would run into hotspotting. So we're going to key by ID, upper ID and base ID. We know that we're going to get an equal distribution because those numbers just generated. We know that it's going to be fine, and that's what we're decide to do. And I have a little star in here because I, wanted someone to say that to me. So when you produce things to Kafka, like how many people have used idempotent or transactional producers in here? There you go. So transactional producers, it's the same as a database, same concept. Either everything goes or nothing goes. So when you produce, if you produce to multiple partitions, either that entire produce request succeeds or it fails. That's the transactional aspect. The idempotent is, as the name might imply, you do the same operation multiple times, there's no effect, right? So that's how you get this idea of, I'm going to be assured that I'm only producing once and only once. Asterisk, because really you have to have a consumer that understands that. And Kafka Streams inherently, when you turn on certain semantics, will understand that. But I put that in there because in order for this to be true, you have to use a single idempotent producer. Semantics. Now, how many people in here have ever seen Highlander? Yeah, see, that's what I'm talking about. Like, my friend was like, you're going to go to Sweden and no one's going to know what Highlander is. I'm like, everybody knows what Highlander is. I mean, it's awesome. Also, yeah, so semantics are also something that people get confused out, and you need to talk about this at the beginning. So by default, Kafka Streams is going to give you at least one semantics. That means that message will go at least once. It may go more than once. It may go 1,000,000 times. How many people here have hit a serialization error and had stuff be reproduced like 1,000,000 times in a second? Anybody? Oh, it's awesome. I suggest you try it, especially if you pay for logging. It's real fun. So that's at least once. Exactly once is so interesting, and I love the way that Kafka does it. So inside of Kafka Streams, the exactly once guarantee does not mean that that message inside of all those subtopologies will be produced only once. That is not what that means. What it means is it will act as if in your source and in your sync topics, it will act as if it was only produced once. So that comes with some caveats. So if you choose at least once, you have to be responsible as an app dev for deduping or blocking. I differentiate. A lot of people don't. I do. Deduping to me means that you have logic inside your application that recognizes a duplicate and says, I'm not going to touch you. Blocking means you can have a table somewhere of already seen IDs, consume a message, and then just bat it to the ground. So those are two different things. You have to do one or the other by yourself if you're going to use at least one semantics. Or maybe you don't care about dupes. Some people don't. I've never found anybody who's like, sure, throw them all in here, but I'm sure there's people. So in here, you accidentally overestimate production, and poor Elaine is fired for theft. And then she vows to seek revenge on you and your family, which is sad for you. It really is. I'm like trying to up the stakes again, and we're getting to revenge. So exactly once. When you spin up, remember we talked about that transactional aspect of producers and idempotent. So what happens is when you use exactly once semantics in Kafka Streams, and it's one setting, which is pretty awesome, it spins up transactional producers and read-committed consumers, which means that you're only going to get that message once through the flow. Side effects do not count in that. Let's say you do something crazy, like call out to a REST service in the middle of a Kafka Streams topology. Ask me how I feel about that. If you do that, there's no guarantee for exactly once. If you're inserting something into Aerospike or you're doing something crazy in the middle of it, no, that's not what that means. You will get a million messages. You may, who knows? So exactly once does not mean inside your topology, those subtopologies, that processing is only going on once. It means that in the source, it's going to be as if it was only done once. And that's an important differentiation. That's because the consumer that's consuming from those subtopologies is only reading committed messages. There's other messages maybe flowing in, maybe dupes. The consumer just bats them to the ground because they're not, because of the transactional aspect. So if you're starting to do side effects, you're calling out to a REST service, you're doing something else crazy, and you have exactly once turned on, there's no guarantee. And a lot of times that happens. And when that happens, that's when you have to manually do deduping and you have to manually do blocking. So right off the bat, if you have to have side effects, exactly once is not for you. So now we're going to get into time. How many people love time in Kafka Streams? How many people have used wall clock time, Kafka Streams? Anybody? Wow, that's impressive. Matthias would love you guys. And that's why I put him on here. He's my friend, and like he hates wall clock time. So wall clock time is the old batch mentality where I don't care. Every 5 minutes, I want you to do this. I'm going to run this job every 5 minutes, right? And that has nothing to do with stream time. So in stream time, we do have windows, right? We have all these aspects in Kafka Streams. We have sessions. We have all this stuff, but it's all event-based. And there's a very good reason for that. It's because that makes it deterministic. And what I mean by that is that since, again, you've got an immutable log, which is beautiful and genius, and you know the order that things are coming in, if things are driven based on those incoming messages, then you can reprocess them with assured. You're like assured that they'll be reprocessed in the same order. So for a window to close, if you're using stream time, it has to be closed by an incoming message, which means that when you replay it, you're going to get exactly the same result. It'll be deterministic. Wall clock time, as I like to say, is subject to outside influence, which means that, let's say that somebody decides to run something and your app's running slow. We don't care. It's every 5 minutes. Maybe you haven't processed the same amount of messages. It's every 5 minutes. So it's not deterministic. You might get different results. Now, that's not to say there aren't use cases for wall clock time. One of the things that I see a lot of is where you have someone and they'll log into a website and they'll make a bunch of changes to their profile or something like that, right? And then they log out. They might not log back in for months. So there's no event to close a window unless you go and you write an event, and people tend not to be as comfortable with that. So in that case, what they say is they go, no, I just want it to close every 5 minutes because otherwise I'll be waiting forever. And then you have to use wall clock time. Now, the Streams DSL is the high level in Kafka Streams. How many people here are familiar with Streams DSL? There we go. Okay, so this is also a point of confusion. The Streams DSL is a beautiful, wonderful thing. It's fluent, it's gorgeous, you just dot, la, dot this, and you're happy all day. It's built on top of the processor API. The processor API is the low-level API in Kafka Streams. The processor API supports wall clock time. You use timestamp extractors that do whatever you want. So if someone tells you, well, you can't do that in Kafka Streams, it's not true. You might not be able to do it in the DSL, in the pre-built functions, but you can always implement it yourself in the processor API. So in our story, we decide we're just going to use wall clock time, but we forget to account for late arriving messages, which is, again, something that you cannot do in the processor API. Kafka Streams is smart enough where it'll say, look, I'll give you a grace period, right? Or don't close this window, or if they come this these messages come 10 seconds later, just throw them in there, right? You can't do that if you're running things every 5 minutes. So that's a problem that people do is they'll say, I'm just going to use wall clock time, and then they miss out on things that are valuable to them. So then I just said your car's towed, which doesn't play very well here because it's so nice. Nobody has cars. I like walking, so I'm very happy in Stockholm. I think it's pretty cool. But again, you ruminate on the fact that wall clock time is non-deterministic as you try to determine the location of your car, #pun. So we choose to use stream time, right? So we achieve deterministic processing. This is also really cool if you do one of two things. You either introduce a bug, which stinks, and that's horrible, and you have to reprocess stuff that you hosed up, or two, and this happens more frequently because we're all wonderful developers, you have something new that comes out and you want to replay data. When people are asking me questions about topology, I would say 57% I don't know why that was so specific, but 57% of people probably ask me about replaying messages where, well, these people, we have a new model. We want to go back a month and rerun it and see what that forecast is. So if you want to replay messages, stream time is for you if you want deterministic results. So now we're going to get to the hardest part of any service, which is state. If you don't have to have state in a service, don't put it in there. I mean, I don't know there's no fun there. If you can have a stateless service, have a stateless service. Unfortunately, that never happens. Like, that rarely happens, ever, where you're like, I don't need any state. So we all deal with this. And if you look at the DSL, stateful things are things like state stores, change logs, which is what backs the state store. We'll talk more about that. Joins, aggregates, anything where there's a combination of messages, where it's not a single message transform. Stateless is something like a filter. Filter has no memory. It looks at one message and it's done. Same with map. It's a message-by-message transformation. So here's chapter 2. This is catching Kevin. So Kevin, and he's coffee break Kevin because he takes too many coffee breaks, but he also sits right next to people on a bus, like if the bus is empty. So like you go on, he's like right there. He's like, hey, which is just rude. And no one does that here. It's great. Everyone like equidistantly spaces themselves. I love this country. I really do. So we're going to catch him, right? Because he takes long coffee breaks and then sits right next to you. He's a horrible person. So I had 2 different chapters, and I put this one first because I think this is the most important, and sometimes at the end of presentations, people tend to check out. So if you're going to check out in the last one, not this one. Whenever you're trying to measure something, I call it the big 3. You need, and like, do make a plan. Don't just like dive in. What do you need to reason about? What do you need to measure? And like, at what intervals do you need to measure it? If you can answer all 3 of those questions, then you can kind of plot this plan, and it makes it really nice to design a topology. So Kevin always works the red line. It's like his jam. And what we want to know is we want to find out, we want to say, okay, well, when's Kevin taking these coffee breaks, right? So we need to measure a production line by color because we need to talk about how fast that line's running, when it's happening, what's going on. So we know we need to reason by color. And in Kafka Streams, it's very easy, right? You group. So if something comes in and it's not keyed by color, that topic, and it really is, you want to dice and slice all this stuff, you can do a group by. So in this case, we're going to group by color. And that's going to give us a nicely beautiful sub thing of groups by colors and what we want to reason about. Note again, we didn't have to partition and we didn't have to key by color in terms to reason about it. Like, don't make that assumption. I see a lot of people who make that mistake where they say, oh, I need to reason about X, I'll key by it. And then they're like, why can't I scale anymore? I have 2 partitions. I'm like, no, it's bad. So the next thing we want to do is, what do we need to measure? And this is like one of my favorite things is session windows. How many people use session windows? Anybody? Oh, they're fantastic, right? Igor knows. Because they measure the absence of something. And in life, sometimes the absence of something can be just as important as the presence. And in this case, that is what we're trying to measure. We're trying to measure the absence of Kevin doing work and sitting next to people very close. It's annoying. So what we want to do here is we want to say we need to measure lapses in upper production. We don't want to measure the rate, really, of production. We want to measure when it stops. And anytime you want to do that, anytime you look at a lapse, you want to use a session window. And those are cool. And this, is used, it's never used this way because I made it up. But most of the time it's used for webs, like engagement, right? When does somebody stop clicking around my website? When do people stop doing this? And so that's usually how it's used. But I love session windows, and I think, they're misunderstood a bit at times. So that's what we're going to use here to catch him is session windows. We're going to measure lapses in upper production. And then at what intervals do I need to measure it? Well, also he takes the last cup of coffee and doesn't make any more. That's rude. You should never do that. So he takes 15-minute breaks. So we know that what we want to know is, hey, if more than 15 minutes elapses, tell us, start a new session, because then we're going to be able to timestamp that and we'll know 100% that he's slacking off. So session windows come with a time unit, very easy. And I just put this in there so you could see it. Obviously, you probably want to put that somewhere else, but for verbosity or whatever, it's there. At the end, we're going to aggregate it. We're going to suppress it, and I love suppress. It's great because basically until we had suppress, which came out, I think, Kafka Streams 2, 3, All of the aggregates every time, like every time an upper would come in, it would output and emit and emit and emit and emit and grow and grow and grow. So suppress is great because basically you can say, just suppress this until the window closes. Don't send me it until it closes. Now I put in unbounded. It depends on your scale there and your volume, obviously. The reason that you can put in a bound is because if it gets really big, you might just want to emit it. So you're not keeping all that state in your application. And then we'll put it to a stream. We'll get all those, and then we'll catch them. We'll bust them with Kafka. It'll be awesome. And I put a little red X on them. So that's that. So chapter 2, because remember the JIRA had 2 parts. That's our PS. How many sneakers should we make in an hour? So what we want to do is the goal here is to say we have this many uppers, right? And we have this many bases. How many? And you might think this would be easy. And I put this as an example on purpose because a lot of times when you're dealing with Kafka Streams, you're like, I'm just going to do this, and it's going to be easy. And then you're like, wait, what? This is not easy. You would think that we could say, OK, every time I get a finished upper in red, I'm just going to group by color. Every time I get a finished base, just join those and then output it, right? It's simple. Except for one-on-one joins aren't currently supported in the Streams DSL. That's not something that you can currently do in Kafka Streams. You can't do a one-on-one join. It doesn't work. And so this becomes a case of, what do you do when what you want to do isn't supported in the Streams DSL, which is another common thing that happens. So you have 2 choices. 1, you can change your topology. Is there a way to achieve the result that you want without doing it in the way that you want it to? Or 2, you can use the processor API, which is what we talked about, and that's that low-level API that the DSL is built off of. It's very flexible, very powerful, and you can pretty much do whatever you want in that. So let's talk about changing your topology. And I wanted to give this as an example because there are a lot of ways, like I said, infinite ways to achieve the same result with given topologies. So when we look at this, we say, OK, what if instead of doing a join, we said, every hour, tell me how many uppers and how many lowers we finished. We should have at least like whatever minimum is. So if we finish 4 uppers in 1 hour and 3 lowers, we should have at least 3 red sneakers because we've finished that many uppers and lowers. We should be able to put together at least that many sneakers. And maybe you take it and they say, sure, that's good enough. And you're like, sweet. And if that's the case, we would do similar to what we did before. We'd group by color. We do a windowed by because, right, we're not measuring lapses in production anymore. We're measuring actual stuff. Give it an hour, count them, suppress until it closes, and then put it out to a topic. Take the min of that, and we should have at least that many sneakers. So I put this in here because if you can't, if the way you want to do something doesn't work, I always encourage people not to quit. Don't just quit on the Streams DSL. Is there another way to achieve that result? And we would do the same thing for bases. But let's say that doesn't work, and you decide, I'm going in whole hog. I'm going to use the processor API. You need to think about what you need to do. So this is an example that Matthias put on a Stack Overflow answer to illustrate how we do a streams-to-stream join under the covers. I mean, there's like 5 state stores. We've got a merger, join, it's not easy. It's not an easy thing to do a join with the processor API. If it was, everybody would use that and not the DSL. We wouldn't even need it. So when we talk about the processor API, it's comprised of the following parts, right? You've got your source, you've got a processor, usually an associated state store, and you've got a sink, right? It's like a mini stream. And so for us, and to make this example easier, I wanted to say, OK, we're just going to do red. So for us, the source is going to be red uppers and lowers because we know we need to do something with those 2. And this is where I always tell people, like, write it down. So what we want to do at the end of the day is we want to emit a pair. We want to say we've got our criteria is, do we have 1 red upper and 1 red base? Oh, look, it's a pair. Emit it. So we're going to need 3 state stores for this. We're going to need 1 to hold the uppers, 1 to hold the bases, and 1 for the pairs. And then in the processor, the cool thing is there's this idea of a context. And the context gives you everything you need to know about the current message that you're dealing with, including the topic name, which can be very valuable because then you know where it's coming from. So you can have a lot of times the same message even produced to multiple topics based on where that message is coming from, the source of it. It can have the same schema. It can look exactly the same, but the topic name might tell you something that you need to know about it in order to, in order to execute your processing logic. So in this case, that's true. We want to say, okay, well, we know what topic it came from, uppers or bases, so that's what we'll know. So the logic is to check in the alternative store. If we get a base, check the uppers. If we get an upper, check the base. So let's take the example of an upper. If an upper comes in and the base is in the store, grab it, remove it from the store, combine it with the upper, and throw it in the pair, right? So we're basically building up this state store of pairs. And at the end, there's an idea of a punctuate. And punctuate is, hey, I'm going to do this, do this, do this, and then every once in a while, forward this stuff downstream. And it may be forwarded to another processor. It may be forwarded to a sink. It's just forwarded onto whatever is next in your topology. And that can be executed at any time interval that you want. So it can be executed with wall clock time every 5 minutes. It can be executed with stream time. You can write a custom timestamp extractor and do it like in the past or the future. You can do whatever you want. And so that's kind of how we would go about doing this. And I have a demo of this too, and on my GitHub repo, which is on the last page of this, if you want to see what any of this stuff looks like. And I have session windows and wall clock time and all sorts of stuff in there too. So to wrap up, I want to talk about RocksDB, not just because we put that prefix scan in there that uses Bloom filter. For the longest time, it was like so inefficient and it was like killing me. But we just did. That's how foreign key joins are executed. How many people have seen that Kafka Streams has foreign key joins now? What? Oh my gosh, it's so exciting. I'm like so happy. So now you can join by foreign key in Kafka Streams in the DSL. And the way that they did that was they used a prefix scan in RocksDB, which uses a Bloom filter, which made me happy because I like Bloom filters. So in the processor API, when you're making these state stores that are backed by RocksDB, there's a couple of types that are already available to you. They're easy to use. You just use a store builder and build them. You can have a key value store in memory session, and memory window. And in memory are faster. So anytime you're using something that's persistent, it's not going to be as fast, obviously. So if you need something that's real quick, in memory is the way to go. You can use an LRU map if you want, if you're feeling, cool. And then we have persistent key value session, timestamp key value stores, which I would encourage people not to overlook because those are very interesting, and there's a couple of kind of real cool use cases for those. Timestamp window store, and then persistent window store, or you can write your own. And people have done that. Some of the coolest state store implementations I've ever seen are custom state stores, where people have a very specific use case, and they want to make it go fast. And everybody loves to make stuff go fast. So we use default, like the default methods in RocksDB. And they're kind of like the generalized ones that work but they're slower on read. So if you need something that's like a real fast read, you might want to implement a custom state store. If you have certain requirements like segments, or you want to do something like, for cleanup, you might want to use a custom state store. If you write a custom state store, we would also encourage you to maybe, if it's super cool, say, hey, maybe this should be included. Contribute, yay, Apache Kafka, for that. And at the end of the day, to wrap it all up, you kind of have this flow chart. So you would start out, and like I always say, pick your key. Do you need to assure order? Yes, no, right? Key by entity or no key? Second, pick your semantics. Do you have side effects? I don't know if you guys heard me say that 80 million times. Yes, you're going to use at least once. Do you have to have exactly once? Because you don't, again, there's a transactional overhead. Those producers that you spin up, it's about a 10% hit in performance. So if you don't have to use exactly once, there's no reason to use it, obviously. And if you do, use exactly once. And then for time over here, do you need to emit every t minutes, irrespective, again, of incoming events, that 5 minute? Then yes. Are you using exactly one semantics? Yes, then you're in danger. And this is because of that deterministic processing aspect we talked about. Every 5 minutes isn't the same for an application executing multiple times when you're talking about what. And we all know that, right? It depends on what else is running. It depends on what's going on. And if you're not using EOS, feel free to use the processor API. And if you can use stream time, I would encourage everyone to. And there are ways to get around the idea that, well, I need it to close every 5 minutes. You can send an event to close that, right? You can use what I would call, would call a time closing event. So every 5 minutes, you send a time closing event. So there are ways to drive wall clock time via events, and that's becoming more and more popular. And I think that's all I got, except for I'll leave this slide up here if anybody wants to check out demo code for Kafka Streams with The DSL, processor API, session windows, derivative events, foreign key joins, it's all in there. So take your pictures if you will. And I think these slides will be online too. And I'm on Twitter. So if you follow me on Twitter, you can have pictures of those cute pancakes that you guys have here. I ate like 50 of them this morning. They were super good. So I guess, yeah, that's it. Time for questions if anybody has any. Thank you very much. And I'm done. Anybody got any questions? It doesn't have to be about this. It could be on anything. I'm good. Oh, yeah, over you.
You never talked about running Kafka Streams and something like in the cloud, like Kubernetes.
Oh, sure.
It just seems a bit, in my experience, complex to do.
Yeah, I mean, it's state in Kubernetes, right? So yeah, it's complex to do. Yeah, there are best practices, and actually, is Tim still in here? Yes, Tim's back there. They were actually putting out like a white paper, and I do believe that, is there a section on Kafka Streams or running Kafka Streams on Kubernetes in that white paper? I believe there is as well. So we're actually putting out a best practice document about running Kafka Streams in Kubernetes. So I would check for that when it comes out.
Where?
It would be on the Confluent website, and we'll tweet about it. If you follow me on Twitter, I'll tag you in it when it comes out. I'm good like that. Anybody else have any questions? Can you ask me about it? Yeah, back there. There's somebody. Or yeah. Okay, say again. For global. Oh, for global stores. The best use case for global stores is when you don't want to think about it. That's my favorite use case for global stores. When you don't want to think about it and you have enough room. Then you should use global stores. Also, if you're doing something like the interactive queries, right? Interactive queries are easier if you can use global stores, because then you don't have to figure out what instance that's in. So I would say those two. Oh, there you go.
Something about RocksDB. Are you contributing to RocksDB, or are you using RocksDB with Kafka?
We use RocksDB with Kafka. However, we do also encourage, and I think we've submitted some patches to get stuff in the JNI, because that I think was the holdup with using the Bloom filter, was that it wasn't available. And that's kind of the ticking point, is like a lot of the cool stuff in RocksDB, it's not always available. And so I do think that we have a couple people that have contributed to RocksDB in order to make that available.
Oh, okay, thanks.
Anybody else want to ask about a specific topology? I'll answer those questions. Love those. All right, cool. Guess I'm done. Was it quick? Did I go too fast? What time is it now? Everybody can have their time back. Oh, I got 10 minutes. Cool. Oh, somebody else has a question. I like that guy. Keep going.
So is it better to put different like sources and sinks and all these topologies in one application and deploy it, or try to like separate it in different deployables?
That's a great question. That's actually a fantastic question. So what I always say is, when you're thinking about it, you should think, do I care if this is broken and this would still work? That's what I always say. So like if there's any benefit to this thing still running when this thing is broken, then separate it, right? Also, you want to avoid dual writes. I mean, how many people love those? They're great. They're horrible. So if you have a case where you're going to wind up with a dual write, and that comes into play with state, right? So if you have something and you're interactively querying that to see the state of something, probably don't separate that from the thing that's updating that state, if you can help it. Because then you might have some disjointedness, you might have a race condition, and you might have inaccurate state if you were to take that and put it in another application. So I guess that's what I would say, is avoid dual writes, and also functionality. Use functionality to determine that. Anybody else? No? Oh, you got one. There you go.
What about running Kafka with one broker on a legacy system? Is that a very bad idea?
Running, sorry, say again?
With one broker, if you have a legacy system with only one server, would it be able to run Kafka anyway? Is it
to run Kafka Streams, you mean? Or?
Yeah.
Yeah, for sure. I mean, the thing about Kafka Streams is, like, it depends on your own use case, right? I mean, if you don't care, like, and there are people, like, people act like there's no ever use case where something can be down for an hour. That's so not true. There's tons of use cases where it's not, you know, the idea that that data has to be like boom, boom isn't true. So let's say that you have a legacy system, super old, you got one server, and if Kafka Streams for whatever reason, if the server goes down, it crashes, you're cool with waiting to get it back up, go for it. More power to you. I mean, you know, it's really, that comes down to what's your availability and resiliency requirements, right? But there's certainly absolutely no restriction. Somebody else clapped. That made me feel better. Now I'm not like so soon. And if you have any questions about specific topology or developing Kafka Streams or contributing to Kafka Streams, hit me up on Twitter. Like, I love helping people, and I love talking about topologies and learning about new topologies, which is why I'm no longer a software developer, and now I'm a technical account manager, because now I get to work with super cool use cases all the time. It's fun. All right, cool. Thank you.